Coming up on This Week in Radio Tech, Tom Hartnett is with us. We're talking about WebRTC. What is it? Why should you care? Well, you should care because it's cool. Chris Tobin joins us too, talking WebRTC as well from his studio in New York. It's all coming up on TWiRT. This Week in Radio Tech is brought to you by Broadcasters General Store with outstanding service, savings, and support. Online at bgs.cc. By the Ruby Console from Lavo. See Lavo in your future at lavo.com/TWiRT. And by Angry Audio. Audio problems disappear when you get angry at angryaudio.com. Hey, welcome into This Week in Radio Tech, the show where we talk about everything from the microphone to the light bulb at the top of the tower and so much good stuff in between. I'm glad you're here. I work for the Telos Alliance, and this is the Telos Alliance studio that I'm in today, as I am most days. I want to thank them for providing a little bit of time off on Thursdays, kind of take off an hour early to do the show, and also for providing some of the gear that we use here in the studio. So that's my perspective on things. In case you don't know, I'm also a part owner of 14 radio stations, and it's true, I do own the part that doesn't make any money. I also do a little weekend weather from time to time on a TV station here in Nashville. So those are my semi-qualifications, and I'm sticking to it. From cold Nashville, Tennessee, but nothing like the Northeast. Let me welcome in Chris Tobin. Hey, Chris, welcome into This Week in Radio Tech.
Well, thank you, Kirk. And sorry. Let me take that prop on here.
What is that?
Well, we're talking technology, and I came across something in my storage at home a long time ago. I actually do use it, believe it or not. It's a product it's a IFB receiver, UHF. It was developed by a small company in Massachusetts, and effectively changed the industry on many levels. So it was pretty cool. Yeah, if you want to see it again, that's what it looks like. It's two knobs, power switch, volume control, squelch, an earpiece. Operates on the UHF frequencies for Part 74 operators, and it is powered by a 9-volt battery. It's pretty cool.
How about that?
Sudbury, Massachusetts. Yeah, FCC receiver. So it's an FCC receiver. So in other words, when the FCC's in town because you'll be receiving them. There you go. So there you have it.
Chris, as I mentioned, it's a little bit chilly here in Nashville. Let's see, what is it? Is it? Oh, it's 41. Oh, it's warmed way up. We started out about 14 degrees this morning here. How about the Northeast? What you got in New York City?
Well, about an hour ago, I checked. It was 17 degrees Fahrenheit. Real feel, I think, was closer to zero. This morning, though, when I was out of bed around 5 a.m., it was 2 degrees, minus 10 wind chill. So it was good. It was brisk. Wakes you up, get you going.
A year ago, it was this cold, I want to say in really early January, because I remember a year ago, I was sitting at our cabin in Gatlinburg. I was sitting in the hot tub, and the hot tub was set to 104, which is as high as it will go. Need to get a new hot tub. And the temperature outside was 3 degrees, and the hot tub is essentially outside. There's a screen, there's a mosquito screen between the hot tub and the outside. So it may have been 4 degrees in the room. So we had 100-degree difference between the water and the air temp. And I had icicles on my hair. It was pretty wild. Yeah. Well, I wonder if it's any cold. Yeah.
I just laugh at all this. Everyone's running around crazy. It's like, my goodness, the weather. What's going on? I'm like, it's January. You should expect this kind of condition.
Exactly.
Just happens,
it did this.
I mean, I have friends who live up in Buffalo and Syracuse, and this is the kind of weather you have in May. So I don't know why everybody's so
well. It is even colder up in Wisconsin and Minnesota. But hey, let's bring in somebody who gives us a weather report from up. Is he in Massachusetts? Tom Hartnett. Yeah. Hey, welcome in. Glad you're here.
Hey, guys. Yeah, Massachusetts, very, very similar situation as to New York, but I don't really buy into that wind chill stuff. We don't. We do the temperature in the old-fashioned way. What the thermometer says is what it is. And yeah, I think we're at about mid-teens here, but that's just typical for New England. We don't mind that a bit.
Tom, I'm right with you there, man. I think we all know that it feels colder when the wind's blowing. I think we get that. So
absolutely.
Doing weather on once in a while we give wind chills, and that real feel, that's a trademark. You can't say that unless you subscribe to whomever owns it. So.
Yeah, I'm not buying that.
So it's cold outside. The window's right behind you? Yeah?
Yeah, and we had a nice little dusting of snow the other day, so it's looking very much like we're ready for February here. But that's February in New England, and it's actually not too bad for us.
We're getting ready to talk about some very cool technology things. Tom Hartnett is the technical director for Comrex. A lot of you know Tom. If you probably seen him at trade shows. Tom is almost always in the Comrex booth, and he writes some articles from time to time, Radio World and other industry trade magazines. So Tom, I've always enjoyed talking to Tom about technical stuff, even though we work for companies that kind of compete in some areas and not in others. But it's always good to hear Tom's take on things. Tom's been a guest before on the show. It was a long time ago, and actually I wasn't on that particular episode. Chris Tobin was, and probably Tom Ray and Chris Tarr were filling in that day. So I'm glad that Tom could make it here today, and I could be here as well. We're going to start off talking about WebRTC and some other cool stuff in just a minute. I want to tell you, This Week in Radio Tech is brought to you in part by my friends at Broadcasters General Store and Inovonics. Hang on, Tom's coming up next.
The Aaron 655 is the latest addition to the Inovonics family of rebroadcast receivers, designed specifically for FM broadcast translators, also referred to as relay transmitters. The Aaron 655 is unique as an uncompromising DSP-based HD radio and FM receiver combined with a powerful 3-band audio processor and dynamic RDS encoder. IP connectivity adds streaming capabilities, and a web browser interface gives you total remote control of the unit from any PC or mobile device. The Aaron 655 gives you maximum flexibility for program sources. Select program audio from analog FM, digital channels HD1 through 8, streaming sources, and analog or AES digital line inputs, all with assignable failover audio backup. The internal RDS encoder allows you to customize your RDS messaging. You can use incoming off-air RDS data, convert HD radio pad data to RDS, convert streamed metadata to RDS, or receive IP telnet data. Comprehensive audio processing includes gated and windowed AGC, a unique syllabic leveler, 3 bands of compression, and both wideband and independent HF limiting. Easy setup is achieved by using 10 factory presets and 10 customizable presets. The processor also supports day parting, allowing automatic preset changes to follow different programming formats throughout your broadcast day. The front panel has an OLED display and jog wheel with intuitive menus for easy setup, advanced control, and editing for all operating parameters. The Aaron 655 dynamic web interface gives you total remote control of the unit from any PC or mobile device. A comprehensive set of menus includes a quick overview of now playing info, input-output control, processor options, RDS encoder, alarms and notifications, SNMP settings, and much more. You can also listen to the live audio broadcast streamed through the web interface.
That is a really cool box. The Inovonics Aaron 655. And by the way, it's available from Broadcasters General Store, who bring you this portion of This Week in Radio Tech. You can contact BGS and go to the web, bgs.cc, or do what I do and give them a call because they are so friendly. It's just always a joy to talk to the folks at BGS. They have them well trained. 352-622-7700 is their phone number. You can find that online on their website, too, bgs.cc. By the way, speaking of Inovonics, in a few weeks, we're going to have either Gary Kuhlman or Ben Barber as our guest. Ben Barber, the CEO of Inovonics. So we're going to find out about some of their gear, some of their technology. I've been using their gear for a long time, so we'll check that out. Hey, you're on This Week in Radio Tech. Chris Tobin is with us, and so is Tom Hartnett. Tom, welcome in. And this thing, WebRTC, I'd love to jump right into that, since that is the technology that drives some of your products and is driving more and more things. This very show, my image is being delivered and my sound is being delivered to the GFQ studios over WebRTC technology. So is yours. So is Chris Tobin's. Talk about what is this thing WebRTC that I first heard of maybe 4 or 5 years ago?
You know, it's funny. You use the term WebRTC, and I've been talking about it for a number of years, and people's eyes kind of glaze over. They don't really get what you're talking about. But the easiest way to describe it is it's a competing technology to things like FaceTime and Skype. It's a video conferencing system, but it's got a lot of elements about it that make it much, much more interesting than the proprietary systems that are out there. It's available now for free, and it is wide open. It's available really to anybody who wants to deploy it or exploit it for a product or to leverage it for a video conferencing system. So it's a really interesting technology, not only from the technical standpoint of it, but from the open aspect of it. The fact that it's completely open source and completely available to all developers.
Okay, wow. I hadn't thought about it that way, that it's really a competitor to Skype and other closed systems. Wow. Now, you said that anybody can put it in their product. And as I recall, when WebRTC first came out, it was only in Google Chrome. Was that right?
Yeah, that's true. But the web browser companies have really decided that they need to do this to compete. And it came very quickly to Chrome, but then not far behind that, we had Firefox coming on board, then Opera, and then further along when the Microsoft Edge hit the scene, they decided they needed to have it also. And most recently, it actually, probably about a year and a half ago, we had the last holdout come on board for WebRTC. Apple was obviously they have their own FaceTime application, and you know how they can get about things that compete with their applications. So with a lot of prodding and a lot of coaxing and a lot of foot dragging, they actually introduced WebRTC capability into both iOS and macOS just about a year and a half ago, which really cemented the idea that this is the way things are going to be done from here on in, because when you have Apple on board, you can actually claim to be ubiquitous and completely platform agnostic.
So, I would dare to say that most radio station engineers, the bulk of our audience, others are welcome too, but most of our audience is broadcast engineers. We're not coders. So some are, but I mean, I used to play with BASIC years ago, but I kind of get some of the ideas about coding. And various protocols that may be in something like WebRTC. So WebRTC, I understand, is a framework, a collection, this thing that's got a lot of tool sets in it. Can you tell us some of the tool sets that are available to people who want to develop communications stuff with WebRTC?
Yeah. So basically, it's a module that's built into your browser that I can, as a developer, write a JavaScript program to just kick in this particular module. It has the ability of grabbing the camera on your computer or your USB webcam. It has the ability of grabbing the microphone on your computer, asking permission to use those things. So you get to click a little "I am okay with this website grabbing my media." And then it has several different audio and video encoders built in. And that's the part that allows you to make a real-time, low delay, high quality audio video connection between browsers. As an example, for video, there's mainly two that are available in most of the browsers. H.264, which is a very powerful and recent video encoder, and also the Google version of that, which is called VP8. So most of the browsers will actually have one or the other or both implemented so that these browsers can talk to each other via video. Now, when it comes to audio, there's a range of choices of encoders and decoders that I can just grab with JavaScript and implement and stream with. The most powerful these days being the Opus encoder. If you don't know what Opus is, it's really become the standard way of doing web audio these days. And we've actually implemented it into most of our products at this point just to be compatible with the way the web is moving, which is via this Opus encoder. So if you buy a Comrex codec or some of our competitors, one of your encoding and decoding choices is now Opus. And that's primarily to be compatible with things like WebRTC.
Okay, so video and audio codecs are they built into this framework, or do they reach out to the host OS for these things, or can it be either way?
Generally, they are integrated into the web stuff, into the browser when you're talking about a desktop or a laptop platform. On a phone, it's a little different. On a phone, it will generally leverage the codec that's been built into the Android or the iOS system.
Gotcha. Okay. Now, if WebRTC, can encompass or calls on these different codecs, does that mean that there is automatic compatibility with one WebRTC program or app to another, or are there other higher protocols that have to match up as well?
Well, there's a piece in the middle that we haven't discussed, which is the WebRTC server. So you generally don't do a direct peer-to-peer connection. It'll be more of a meet me bridge type thing, where everybody will click a link and they will all be logged into this server or a conference room, if you will, like we're doing here. And so the server, if it detects that, for example, somebody's on a video codec that's H.264 and somebody else is on the VP8 codec, it's going to be responsible for having to do that transcoding. So that's kind of built into the server side of the system.
Okay. So typically to use WebRTC for real communications, you would have to have a server somewhere that people are calling into. You said it's typically not a peer-to-peer connection.
That's correct. There's lots of free and low-cost services out there that will deliver you WebRTC. There's and most of them have the capability of just seamlessly transcoding from one audio or video stream to another.
Do you think that did Google put together this WebRTC open standard such that to help them promote Google Hangouts? Because that seems like that's the first way I remember perhaps using it.
It was a key piece of the development of Google Hangouts, but it's basically Google being Google. They believe in non-proprietary systems to a large extent. Take a look at things like Android and the other things they've accomplished. So they just decided at one point that having Skype and FaceTime and all these proprietary video systems just wasn't in the interest of your developers. And I completely agree, because I've gone to a lot of conferences and read a lot of articles about WebRTC, and having this wide open and available to anybody who can code JavaScript has been an incredible driver for innovation. You've got all these companies who've just now decided that they can get in the video conferencing game, or they can leverage this for example, for doing customer service on their website. So that if you log into somebody's website and want to have a video chat with a sales guy or a support guy, you can now do it via WebRTC. So there's all this innovation that's happening that really couldn't happen if you had a closed proprietary system that had to be licensed directly for a fee to everybody who's using it.
Wow. Okay, that's kind of mind-boggling, and the fact that manufacturers, and we'll talk about now what Comrex has done with WebRTC. What was your first? What did you saw it WebRTC? Ooh, what can we do with this? What were your ideas?
Yeah, well, and we still have ideas, and we still have a lot of things cooking back in the lab, because we are still really excited about it, even though it's been really available in the majority of the browsers for coming up on 5 or 6 years now. But I first saw it, and I'm primarily an audio guy, and when I first started reading about it and experiencing it, I noticed that it really sounded good, and sounded better than the audio codec, for example, being used in Skype. So I got really interested in the idea, as I always do when I see a new technology. How can my customers, my radio and audio streamer customers, use this, and how can I make it easy for them to use? A lot of I'm in the remote broadcast gig, and I make hardware, but there's also WebRTC alternatives out there as services. IPTTL folks might be familiar with, and they might not even know what's under the engine, but that's a subscription service that you can use to do your remotes, and that's all based on WebRTC as well. So yeah, it was primarily, when I first got started, about the audio, because I had a lot of respect for the Opus encoder. And like WebRTC itself, the Opus audio encoder is free and open source, and has it basically anybody can grab it and go. So that's kind of what intrigued me with it. It quickly became the web standard because it competes with a lot of audio encoders, which are wonderful audio encoders, like, for example, the AAC family. But it actually has the capability of being deployed at no cost. So it opens up all kinds of innovative ideas for people.
Talk to me about automatic scaling of the encoders with available bandwidth and how that might occur. If you've got a great connection, and I've got a pretty good connection here at my house, and I think my video arrives pretty nicely up at the GFQ network. Yours is looking good. Come back here. Chris usually looks good too. Sometimes he's on a crazy catch a bottle Wi-Fi, and it still looks pretty good.
Yeah.
Are both the audio and video codecs auto ranging?
Yes. On top of the encoding and the audio encoding, video encoding layer, there is a reliability layer built in all this stuff. So it is, kind of testing the connection, doing sending out test messages back and forth, getting a sense of the round trip delay time and the amount of packet loss, and feeding back and forth to each of the clients information about whether they should be throttling the codecs. And all of the video codecs and the Opus audio encoder are all capable of being throttled in real time. So that works quite well in the system.
Wow. Okay. Huh. Yeah, I guess my experience with WebRTC has been through a lot of Google Hangouts, and sometimes with as many as a dozen people in the Hangout, maybe more than that. It always amazes me. And Tom, if you don't know, that's great. But when I'm on a Google Hangout with a dozen little, post and stamp people in there, is the server making like a feed for each participant that has the video from all the other participants in it?
Yeah, well, in the case of Hangouts, it's a little more complicated because Google's got the infrastructure to actually, produce a custom encoded field for every one of the participants with those little thumbnails on there. So there's a lot more you can do, although it is WebRTC under the hood. The Google server has the complexity to be able to create custom feeds each way. What we're doing here, I think, is a little simpler, where the majority of what's being sent back and forth is just video and audio content.
So talk to me about productizing WebRTC. I understand this is in your Opal product. Talk about that if
yeah, sure.
Right.
Well, as I said, I got excited about it early on, primarily due to the audio, and I would talk to people about it, and I'd say, WebRTC, it's wonderful, you really ought to try it. And in that point, you could try it basically between computers, and they'd get a little glassy-eyed and say, oh yeah, that's great, and what else you got? So I decided that the only way to really get people interested in this concept was to make it simple. We had to really introduce something that they could take a look at and reasonably say, okay, I want this because it is incredibly easy to use. And, both you and I have companies that really specialize in doing things like telephone hybrids, boxes that you use to take a call from the mayor or from an athlete and put on the air. So I envisioned this idea for radio and for streaming, audio streaming, as something that would replace that. So if we made it simple enough to actually allow a politician or an athlete to call in and do an audio feed, then that would have real appeal to our kinds of customers, because they certainly are. But, I'm always about trying to get telephone quality off the air of the radio stations. I built a whole career on that. That's been my thing for over 30 odd years. So this ability to actually replace the telephone hybrid and take calls, from maybe expert guests or athletes or politicians, or even, there's certainly no reason that this technology couldn't be used for listener call-ins and have listeners call in and sound like they're in the studio. Maybe some stations don't like that, maybe some stations like the fact that their callers are inferior sounding to the host, but I think it sounds great. So what we ended up doing, I'm sorry, what we ended up doing, let me just grab a little box here, was to create a little simple device that really is, the idea is basically it's just got an Ethernet connection, a couple of audio connections, and then it allows you to send a link to somebody. We call it an invite. So if you wanted to have the vice president or the mayor or somebody on the air at your station, you log in this little box and you just extract what is essentially an internet link, and you send it to them via email, or text, or however you want to get it to them. And they have the responsibility of clicking that link and not much else. So you really can count on non-technical people to be able to do that. Once they click that link, their browser wakes up and it delivers a wideband, low delay, Opus encoded call back and forth to the box. So it makes it incredibly easy to have people call in not on a telephone.
Gotcha. Okay. How and I'm sure you've been asked this before, because I've been to stations, particularly in the UK, where they do use FaceTime, because most celebs know how to use FaceTime. Anybody with an iPhone probably does. What's the experience of using a product like Opal that's meant for broadcast versus finagling up some way to put a FaceTime audio on the air?
Yeah, well, there's always that. First of all, when you use a proprietary system on the air, there are legal complications. For example, if you're using Skype on the air, there are attribution requirements. You might have heard stations saying, here he is via Skype, and you have to attribute that call's happening on Skype. So that's one problem. But as you say, hooking in a computer into your console, while maybe with virtualization is becoming a little easier, it's still not as elegant as something that would sit in your remote rack that has XLR connectors on it. And the other thing is somebody who you can call if things go wrong. If you're running just a general WebRTC service, you try to call and get support at that minute, you're probably not going to get there. So certainly I think a simple little box that's broadcaster friendly and has the right connectors and has been thought out to really integrate with a broadcast workflow is what we're going for. And beyond that, just keeping it simple.
You know what? One reason that's to do it the way you're doing it, it has to do with privacy and security. Because if you're running FaceTime, and the stations I've been to in London would have this beautiful rack room full of computers, and there's a couple little Mac Minis sitting there. And I love Mac Minis, but they're there for the one purpose of taking FaceTime calls, right? And similarly, you might have an Opal sitting in your rack because you're going to take Opal calls on that. But with Opal, you're saying that it generates a link that you send to the celeb, perhaps that you want to interview, right? Whereas with FaceTime, anybody who had your number could call you, I suppose.
That's true. But you can disable these invites, so they're reusable until you tell them they're not reusable. But from a technical standpoint, our product actually contains both that middle server we talked about and one of the clients. So in that hardware box, you're going to actually put that on the raw internet, and it's going to serve up the page to the caller. That's going to give them a little audio meter, and it's going to give them a connect and disconnect button. So it's acting as that middleman, as well as the client that's sitting in the studio that's replacing that computer would be replaced with.
Oh, so I thought you guys had a server sitting out somewhere that does that.
Yeah,
no?
That's actually coming online this year. We're going to be going that way also. Right now, you buy the product and you set it up as your server. And it gets a little complicated because, as you mentioned, security, WebRTC is secure. And as part of that whole process, you actually have the requirement of putting web security certificates on the box, because the web browsers will balk at connecting to the box if they don't have those security certificates, which also means you have to have a domain name for the internet connection you're using it on. So that gets a little bit complicated on the initial setup. The benefit, of course, is that it's extremely easy to connect to once you have it set up. So we're actually going to be offering an alternative we'll call Opal Cloud coming up this coming year, which will the server will exist in the cloud, and the box will be more of a dumb client and just get the audio processing done, and the server remains out there.
Tom, there's nothing better than having a customer of yours do your demo for you. So Chris Tobin is standing by, and I think he's got some kind of demo here. Chris, what you got?
Well, to just show this is what it looks like. Let's see if that works.
I know it's hard to shoot that. So it's so bright.
Yeah. Well, anyway, when you do the Opal, and we've been using it now for the last year, and actually, to Tom's point with the computer and stuff, and Kirk, when you talk about having Mac Minis in the rack and wonderful things with FaceTime, we early on were using FaceTime for interviews with artists and members of our organization. And the hardest part I had, to Tom's point, which was the broadcast workflow, was trying to get the FaceTime product to work with what we needed, because, oh, by the way, make sure that Mac Mini has a camera plugged into it. Then you got to make sure the person using a FaceTime understands what they're trying to connect to and do this, do that, and everything else. Yes, it works great for certain things, but in a broadcast environment, as we know, it can be a little dicey. So mission critical stuff, the Opal product we discovered and went with and said, okay, let's see if this works the way it should, and it does in the short order. So to tell you, you send a link from that Mac Mini you would have just put in the rack and did nothing else but FaceTime. You can now use that Mac Mini to send links, and you send it to your, the person you want to talk with. And what you do is you press, they get a little screen pop up, and they have a choice of using the Opal app, was Opal Connect, the application you can download for, you say, iOS or app for Android, or you could just use the browser built into your phone, and then it asks you if you like to connect through a headset, which we prefer, or use the speakerphone on the phone, speakerphone option with echo canceling on the phone, which I can assure you doesn't work 100%. We have tried it a couple of times. So just for demo purposes, I'll click on this. So then you click on it, and it gives you a screen for your person. It doesn't have to be technically inclined. And I can tell you a story in a second. It gives you a choice of, thank you for calling, it says, press connect to talk to the host. You press connect, like so. I just connected, I hope. There we go. And let's see if this works. And do you hear that?
Sure, yeah, we hear it.
That's the studio across the hall. One of the guys is doing recording, and that's where I have my Opal. So I just connected. I can now have a conversation. Did you see how quickly I did that? Did you listen carefully? Notice I didn't have any issues with the computer and bonking noises or anything else. And that's one of the great things about the WebRTC approach. And we have used this product, and yes, I guess I could say it works, and the technology is excellent. You need to understand your workflow, your setup. We had an interview with a person back in October. She is 87 years old, sitting in her apartment in Chicago, I believe, and using her iPhone in the kitchen with a little headset. We did an interview that later would be broadcast as part of our promos for a membership drive. It was an artist. Then we did the same with another artist. He happened to be traveling in Europe, and best he could do, he couldn't get to a studio, even though we were trying to make arrangements. But so in his hotel room with his phone, we sent him a link, and we did a complete interview, and that also aired with no problem. And we did some stuff with a couple of national networks in the public sector, a public broadcast sector, and have done many things. So last minute, the Opal product has been working out very well. And the nice thing is, as Tom pointed out, and I totally agree, and that is the box goes in the rack, and you set it and forget it. Everything is where it should be. So the people on the production side or operations side of what you're doing, just open up the application, click on the link. What I've done is created little profiles for each show. So the different shows that need to talk to people have their own link, and they keep reusing it. This way, there's no confusion. Because the other part of it is when they connect, you can look down at the box if it's in the studio and see there's a connection, or you have the web page up on the computer and you can see when someone's connected, and you know it's your person because your link has an ID on it. And that's how you can use it. So the workflow part is ideal, and the way it's been presented through the Opal is even better. So could you use FaceTime? Absolutely. Could you use Skype? Absolutely. Could you use some other products? Absolutely. But when you really sit down and think about it, why do I need to dedicate a computer that hopefully won't go batty on me when I have a box that can be focused on one thing, use the technology that the computers use, but know that it's always there when I need it. Because in broadcast, what is it again? Right. And it's there, we need it. We don't have to ask questions or boot up. Just like like this device here, this little thing here, the telephone. You ever ask if there's a dial tone? No. You just pick up the handset. I could tell you, using Opal, you just pick up the phone and click the link. It actually works really well. So for what it's worth, that's my experience with it. And I have to say, it's very, very handy. And the quality, as Tom pointed out, is ideal. And thankfully, we do enjoy making sure our guests on the phone or our remote connections are studio quality.
I enjoy understanding the technology, this WebRTC behind this, and then how a company, Comrex and Tom Hartnett put this into a product. Hey, we've got to take a quick break here. You're watching or listening to This Week in Radio Tech, our 429th episode. By the way, that means next week is a War Stories episode, and we've got a real war story here next week, so hang on for that. Our show is brought to you in part by Angry Audio. Let's take a look at Angry Audio's newest offering. Studio guests are only human, and humans cough, they sniff, and they clear their throats, even on the air. You can cure this with the Angry Audio Guest Gizmo. Press the cough button, mute the mic. Every guest needs one. You know what else guests need? Headphones, which is why each guest Gizmo also has a studio quality headphone amp with individual volume control. Anything else? Well, you've seen those mic arms with the built-in LED tallies? They're beautiful. But how do you light them up? Guest Gizmo does that too. Illuminating, yes, the red light whenever the mic is hot. And installing the Guest Gizmo in your studio furniture could not be any easier. You just need that, a 2 3/4 inch hole saw and a steady hand. You don't have to have a router. Your studio gets a clean custom appearance and you get all the credit. Check out the Guest Gizmo and all the other cool gadgets at angryaudio.com. And those gadgets are available from a number of your favorite dealers, including Broadcasters General Store. Angryaudio.com. You're going to like what you see there, so check it out. It's This Week in Radio Tech, our 429th episode. Kirk Hartnett here, Chris Tobin's along, and Tom Hartnett. He's a technical director for Comrex is here, and he's been explaining WebRTC to us. Tom, before we move on to a different topic, is there anything else you want to say about WebRTC?
Other than the fact that it's what's happening on the web, and it's one of these technologies that everybody has now in their pocket. So I'm just really excited. I mean, we've been selling audio codecs, you and I, for a lot of years, and the ability to just now every copy of Firefox and Chrome and Safari, and they all are an audio codec now. So that's really enabling and exciting, and we've got other stuff cooking. So watch out.
All right. Well, we'll be at NAB. Oh, that's right. I think you said. Anyway, we'll skip that. Let's see. I want to talk a little bit about something else, kind of technical, and then toward the end here, we're going to chat about your live shot video product, because I think more TV and more radio stations are going to be needing to do that kind of thing. But wanted to chat about AES 67. That is becoming such a ubiquitous standard. I mean, since the TV industry is going to that via SMPTE 2110-30. So as TV stations over the next years migrate into totally IP video and IP audio along with that, the IP audio is AES 67 essentially. And so, broadcasters, radio broadcasters, and equipment manufacturers have been incorporating AES 67 now for a few years. Tell me about Comrex. Or tell me about, as an engineer designer yourself, what's it been like integrating this AES 67 standard that hey, it's got to be worthwhile to do, because once you do, your gear talks to lots of other people's gear. I imagine it, talks to Ravenna, talks to anybody that also does AES 67, like Axia or Wheatnet or Ravenna or maybe Dante. So, What are your thoughts about that?
Yeah, I'm really living it right now, because I'm in the process of really doing my own plug fest here and making sure our new AES 67 compatible products talk to all of the major systems. It's very frustrating. Anybody who is at all familiar with AES 67 will immediately say that it's an incomplete standard. It doesn't do a lot of the things that would make your life easy. It doesn't do things like discovery, and it's going to be a pain in the neck to a large extent, hooking incompatible systems together for a long time until the standards committees can finish the process of standardizing how all this stuff handshakes and works nicely. AES 67 is really just the fundamental protocol for moving audio between boxes, but it doesn't do much more. So everybody, built, rightly so, they built their proprietary handshaking protocols and then layered an AES 67 compatible way of doing things on top, much like the way that our audio codecs talk together. There's a basic fundamental standard there, but we've layered all of our, we were there first in a proprietary way, and then the standards came along and we had to kind of layer that on top of what we were doing. So it makes for an imperfect world, and it can be a little frustrating at times, but the standard is there and it does work, and it's been an interesting year coming at this from more of an agnostic standpoint. I think most of the people who've implemented AES 67 have come in from Axia or from Wheatstone or from Ravenna, where we came in with okay, let's build something really that we're not going to brand any of those things. We're just going to call it AES 67 and make sure we hammer out all of the inconsistencies so we have the easiest path to getting people talking on all those systems. We're a little bit it's a little bit harder for us when we're talking audio codecs or hybrids or things like that, because those are all two-way devices. So we need to not only ingest AES 67 from every system out there, we also need to deliver AES 67 to every system out there because it's all duplex. So it's been an interesting time, and certainly some of the participants in the AES 67 standard are really interested in making sure compatibility exists. And some of them are more interested, honestly, in paying lip service to the compatibility issue and then really promoting their own on top of that. So,
yeah, that's a good point. And when AES 67 first started, my employer, the folks at Telos, had we implement on day one of the standard. Telos had a product, the X node, that right then that day could do AES 67 in and out. But we viewed AES 67 as not nearly complete. Of course, I work for Telos, so I can talk about Livewire pretty authoritatively. It was so convenient. It's point and click and very little typing, and it's easy to make routes. Well, with AES 67. Have you ever gone up to an airline counter and asked to change seats, and about they type and type and type and type and type, and eventually you get a different seat? Why does it take so much typing for them to change your seat? Well, it's kind of like that it has been like that with AES 67. It's a lot of typing. There's these little SDP files, and you got to get the syntax exactly right. And it has been a pain. And we viewed it, I think as a lot of other people did at first, as well, if you got to hook two things together that are different, well, you can use AES 67. And that's the way we looked at it. But now, since television is adopting AES 67 as could be their only thing, everything's got to speak this stuff, and it's going to have to be a little easier to get things to connect. So I'll just mention the folks at Telos. They have a new console now, this IQX, and it's an AES 67 console. Now it'll ingest other stuff. It'll ingest different types of Livewire streams, and I think it may even ingest Ravenna stream. Yeah, it'll ingest Ravenna streams, but it only puts out AES 67. That's it. Now, luckily, most other Livewire gear, the newer stuff will also ingest AES 67. So there's no problem with that, as long as it's all newer stuff. Tom, do you see manufacturers? I mean, I'm kind of limited in my view with Telos. Do you see other manufacturers also thinking about shifting their idea about AES 67, where it's going to be the standard everybody does eventually?
No, I can't say that I've experienced that, but I will say that the headaches of interoperability are very much on the front end. You're sitting there with a live wire plant or a Wheatstone plant or something, and you're going through the process of getting this AES67 stream into your routing system. Once that's done and is defined and working, the day-to-day operation is not impacted by this, because you're not pulling and changing and changing STPs and such. So it's really all front-end loaded, which makes it a little easier. I mean, you have a decent technical staff generally at these places, and we intend to have a really good set of cheat sheets available for each of the major systems, so that we can take you through step by step on actually how to get all that piece together.
Gotcha. Chris Tobin, are you doing much AES67 around your world?
At the moment, no. We're not getting impacted, touched by it or anything at the moment. So I'm just watching from the bleachers and see how things go.
Yeah, well, and that's what I did with the original AES. Chris, you and I are have been in very different markets, and all of my stations have always been small town stations. We were analog until it hurt, and that's a bad way to say it. Analog's fine, but we skipped the whole AES3, the AES EBU standard, because we just didn't see an advantage for it, and it required us buying new equipment. So we didn't do that. We just leapfrogged to the audio over IP world. So yeah, I missed that completely. But you'll end up running across it. It was interesting. A couple of years ago, Patrick Kalani at Yamaha invited me and invited folks from QSC and Ravenna to and folks from Yamaha were already there with some Dante gear, and we made everything talk. This was 2 years ago, and it wasn't easy. It took a day of setup just to get everything talking to each other. But once it did, it worked fine. And I think, Tom, that was what you were trying to allude to there, that once you get over that pain of getting things to connect, it does work.
It is, and it's scary that the actual developers of these systems had such a hard time hooking them together. You can imagine trying to have a customer do that. It's not going to work out. So I think the best we can offer is some good support and some good manual writing to basically take you through the different steps. And it's not it's one of those things where you're going to actually have to RTFM, as they say, it's not going to be an intuitive hooking together. So that's the plan anyway.
I'm sure there are deeper problems than what I would describe here, but every AES 67 stream has an SDP, a session description protocol file associated with it, and this is just a little file typically that describes here's my sample rate, and here's how many channels I have, and here's my my multicast IP address if I'm doing multicast, or here's my SIP address, and now I believe, if I'm not mistaken, there's an SDP version 1 and an SDP version 2, and some early gear obviously spoke version 1, may not have been updated to speak version 2, and later gear may never have been written to do version 1. So you could have some incompatibility there. But we ran into little niggling things like you need to add a semicolon to the end of that line and it'll work. And sure enough, it worked. So typical development problems, not good parsing of a file, not enough leeway in a syntax error. That's the kind of stuff we ran into.
Yeah, and you get it in the world of voice over IP with the SIP protocol, which also uses a very similar structure with SDP. And it's always, your syntax is one thing. The bigger problem with AES 67 is there's no standard way of actually transferring that SDP from one box to another. So you don't, and you're in a situation where you're actually side loading a file into your system in order to get it to know what it is you're sending. And that's a little bit inelegant to people like me who like to have the plug and playness of things. And until everybody gets on board with discovery and SDP transfer, it's just not going to get any better.
Well, with LiveWire, and I'm sure with WeDet too, you click stuff connects. I know that in LiveWire gear, you click on the SDP link, and it'll automatically copy paste to your clipboard the SDP file. And so then you just go to the other device where it's needed and you paste it into there. And it should work if the syntax is right.
Yeah, but that doesn't sound like the way things ought to work to me.
No,
Side
it
loading an
doesn't.
SDP file. We were actually doing that in the voice over IP world in the early days too, and it's really kind of. And also in the video codec world, we were doing that. And we got to get away from that. That is user unfriendly in my mind.
Yeah. Yeah. Well, it's better than typing at all, but you're right. There's and I think as the world of TV, big deployments, lots of money, they're going to put up with that. So there will be more standards. It may be a de facto standard developed, or it may be some something from AES. Who knows what it'll be, but there'll be something, just like VHS and beta. We'll have both for a while.
I imagine so.
All right. Hey, I want to move to talking about live shot. I do a little bit of TV work, and occasionally around TV stations, I see what is it, Live View, and maybe there are some others that you pay some company a lot of money every month, and you've got this backpack looking thing, or a thing that fits on the top of the vehicle. It's got up to 8 USB modems, or some kind of modems tied in there, and it looks like a lot of technology. And then for some years now, I've been watching your live shot product, and it's got 2 USB, radios on it. Tell me about what live shot is and why it seems like your live shot product looks a little simpler than the other things I've seen.
Yeah, Live Shot came out about 5 years ago. It was the product of about 3 years of development effort. Really, it was the product of people coming up to us at trade shows and calling us on the phone and saying, "Hey, I do both radio and TV, and it's incredible what you guys have done with radio on IP codecs. Can't you do that for us TV?" And this was, before we had, and we do actually have about a couple of dozen systems out there that do this now. So we went into development on it. And came up with, as usual, we have 2 little boxes, but this is the remote broadcast end of things, and hooks to the back of a camera, and takes in your video and audio input, usually via SDI, but it has other options too. And as you say, we've got a couple of network ports here, along with Ethernet and Wi-Fi. The basis is that you click it to the back of the camera, you hook in the video, you push the button, and you go live. And we try to keep the delay down to a small fraction of a second, and that enables us to do interactive, which is very important in the video world, because most of the time you have a reporter out there at a school or a town hall, and the hosts of the newscast want to chat back and forth to them. And that can be done, obviously, with audio only, with a pocket receiver of some kind. But we've actually enabled reverse video in this product. So you can actually have what essentially is a video conference back and forth to your reporters. And the delay is kept low enough that you don't step on each other and have a real hard time with that.
This was new information to me. I've never been a reporter out in the field, and I've actually never, even though I do weather, I've always done it in the studio. I've never been doing weather from the county fair or from the back porch of the TV station. I didn't know until you told me yesterday that most of these video wireless remote systems don't have a reverse feed. They're a one-way feed only. That's amazing to me. And now I realize reporters all the time get audio-only cues. I get that. With microwave systems, those have traditionally been one way. But live shot is two-way. So they put a monitor out there so the reporter can see the return video?
Sure. We in radio, we're used to full duplex because all of our ISDN stuff, all of our POT stuff, all of our IP stuff is full duplex, because why not? When you get into video and you have to build a video encoder and decoder into each side of the link, it gets a lot more complicated. So at that world where reporters have been doing, as you say, they've been using the Death Star trucks and they've been using the microwave links for years, and without any return other than just these days generally done by cell phone. But before that, it would be an RF link back from the station, or a telephone link that would be then transferred over to a short-range wireless link. and they're used to that, and it's fine. We've decided when we built the live shot that it wasn't impossible for us to do return video, so we decided to add it as an option. So yeah, indeed, you can put a little monitor on top of your camera, and you can aim it at the talent, and the talent can see things happening. For example, if the studio is running an actuality or a taped portion of the newscast, the reporter can sit there and watch that in real time and know exactly when his cue is happening, both from an audio and video standpoint.
You said something yesterday that blew my mind, is when you said that as a weather guy, I could have a green screen out on remote. Like I could be at the county fair, right? And one of the walls of our tent is a green screen. And I could send me in front of a green screen to the TV station, and they could chroma key it there and add the weather graphics and return it to me. And in nearly real time, I could see myself pointing at the lows and the highs and the fronts and that kind of stuff. Is that right?
That has been done, and it was a lot of fun. Yeah, I don't remember the actual name of the station that did it, but and you'd have to get used to obviously a fraction of a second lag between yourself and the chroma keyed version of it. But it's an interesting idea. It's things you can do with full duplex that you can't do with one way.
That sounds crazy and so cool. I'd love to try that out sometime. Is there anything about the technology in live shot that you can talk about that is either different or better or just more exquisitely executed than your competitors are doing?
Let me go back a little bit to the audio codecs, because we introduced ours in the early 2000s of 2005, 2006, and in those days, they were relatively simple devices. The internet was becoming something that could maintain a very simple UDP stream from point to point without a lot of error correction. We did a lot of work on the decode buffering in order to make those internet connections reliable, but there wasn't a lot of magic on the transmit side. It was pretty much just shooting a stream of bits right into the network. When we got into video, we quickly realized that really wasn't going to work for video, because you're talking about a huge amount of bandwidth, generally 10 to 20 times the requirement for audio. And the internet likes to fail a lot more when you're pushing hundreds of megabits through it, as opposed to hundreds of kilobits through it. So we found pretty quickly that, well, as everybody else did, that the networks of the day really couldn't support the kind of HD video we wanted to move, so we had to go to multiple networks. But also that we really needed to take a look at the way these streams are delivered between our boxes. And we needed to add a lot of hooks into what we're sending. We needed to add a lot of forward error correction. We needed to add a lot of ARQ type error correction. We had to we had to find a way to split that stream into multiple devices at the same time. And particularly since we were talking full duplex video, we needed to do that in both ways. So we created for the video product a new reliability layer that our stream would ride inside of. So we would actually technically create what was a VPN between those boxes, between each of the network devices being used in the link. And we could then not only split the data between the multiple modems, but we could also really apply a whole new reliability layer to it. So we gave that a name, and we called it Crosslock. And it was very successful. And I really can't speak to how effective the reliability layers of the competing products are, but I can tell you that we were just blown away at what it could do on really marginal networks. When we were first testing this, and the killer combination of a forward error correction and an ARQ style error correction only when necessary, really just, we had to do a lot of fine tuning, but when we got it right, man, it just would sing on barbed wire. It was really, really, really powerful. So that was the key to making video work. It's relatively easy these days to encode video and stream it. We're doing it as we speak. But to create this reliability layer that would adapt and would correct and would make these bad internet connections that really weren't interested in carrying megabits from point to point, make them reliable was the key to it. We then, after that was finished and shipping and successful, took that reliability layer and moved it back to the audio codecs. So you now have a choice in our audio codecs of doing your streams the old-fashioned way, which is fairly primitive, or applying this reliability layer to the audio connection.
This hour has flown by, and we're going to go over just a hair. We're going to take our last quick break, and when we come back, I don't know if we're going to do a tip of the week, or Chris, maybe you and Tom would like to just dish for a minute on some of the good ways you've put the technology that Comrex puts in their boxes to use. So you guys be thinking about that, because Chris hasn't gotten much of a chance to talk. I'm sorry about that, but hey, Tom's here. That's what he's supposed to be doing. Our show is brought to you in part by our friends at Lavo. Let's hear from Lavo. We'll be right back.
There has probably never been a better time in history to buy a new radio mixing console. Today's consoles are more sophisticated than ever, with more features and functions than you can shake a stick at. But have you noticed how complicated they are? There's a sea of knobs and switches and displays and buttons. Some of them look like you might need a pilot's license to do your show. Well, a board doesn't have to be complicated to be powerful. Just look at the new Ruby mixing surface from Lavo. The first thing you notice is how smooth and streamlined it is. Ruby has lots of cool tech, but what it doesn't have is that confusing ocean of buttons that clutter things up. Now, we all know that there are some console features the jock only uses once in a while. So why dedicate controls to them? Ruby fixes this problem by moving those once-in-a-blue-moon controls to a touch-sensitive, customizable GUI that happily shares screen space with your other studio software, helping you fight control room clutter. Thanks to this design innovation, talent that use Ruby produce smoother shows with less errors. Controls that are used the most fall naturally to hand, while functions that rarely need adjustment are easily controlled with just a couple of clicks in the context-sensitive GUI. And Ruby has cool features you won't find on other boards, like Auto Mix, an intelligent gain writing function that guarantees the perfect mix for multi-mic morning shows and call-in segments. Dual mode snapshots that instantly switch the motorized faders between on-air and production modes, and enough DSP and I/O options to make even your pro sound pals green with envy. And because quality is as important to Lavo as it is to you, every console is proudly built to fanatically precise standards at Lavo's own factory in Germany. If you're ready to declutter your control room, do yourself a favor. Check out the new Ruby and the other cool Lavo radio tech at www.lawo.com/TWiRT.
Thanks to Lavo for sponsoring This Week in Radio Tech. All right, it's Kirk Hartnett along with Chris Tobin in New York and Tom Hartnett with Comrex. He's the technical director there. Chris, you got any last comments or questions for Tom? And I'll shut up here.
That's all right. That's all right. I gave the floor to the gentleman from Massachusetts. That's fine. No, to those watching and listening, I would suggest, and I've done this for many years, but when it comes to IP, and Tom would agree, make sure that your internal networks are robust. Make sure you've done proper housekeeping of your network and where you place your codecs, both for video and audio, because I'm doing both here. And I can assure you that if you're not using VLANs or properly segmenting your network segments, then you should probably start learning that, because do not think that putting your, say, in this case, a Comrex Access or Bricklink or an Opal on the same network as the traffic department and the entire office administration non-broadcast revenue network will not have some repercussions, as Kirk finds out with his 37 tabs in Chrome. That's going to happen. So if you want something reliable from you, in this case, since we're talking Comrex IP devices, I would suggest making sure you place them properly on the network where they can get the most packets, minimal jitter, drop packet loss and everything else, and learn the diagnostics. I know from experience from using the Access on many occasions and many strange and how would you say stressful locations, use the diagnostic tools within the box. And watching several demonstrations of the live shot, the video, the same thing. Learn the devices, learn the networks, and when you're out in the field, take control. If I can tell you that I've worked with the other boxes that compete with Live Shot, and I still think that Tom and his team, their approach is still the better way. And I'm just going to simply say the more little modem devices you stick on a device, the more specific absorption ratios you got to be concerned with. That's about all I'm going to say there. Otherwise, as always, document and make sure your network is robust, and you'll be able to get nice remotes and make some money doing it.
Tom, any last comments for our listeners you'd like them to walk away with?
Yeah, Chris's point is important because a lot of our support, people are out in the field on 4G modems and things aren't working the right way, and they are assuming that it's this unknown. It's the wireless side, and a lot of times it turns out that it isn't. You gotta check your studio stuff. It's very important, we provide ways to do that from the shop, but also the diagnostic tools are built in there, so use them. I do want to say one other thing, which is an apology to any of my friends in Los Angeles for this upcoming weekend, because I am a New England guy, born and bred, so sorry to say, but I do expect this to be a decisive victory this weekend, so I'll leave it there.
Tom plays the goat.
We shall see. Now, obviously, living in Nashville with the Titans here, and they're all at home. I have no dog in this hunt.
I'm just going to go with Patriots just for the fun of it because it annoys everybody I go to the bar with. So I'm gonna
Who can I annoy the most?
I'm having fun. I'm walking in. I'm going to say, hey, I'm talking to Tom Brady. Get out of here. Get out of here. I'm talking. So it's going to be good. I'm going to have some fun.
Is that coming up this Sunday?
Yes, it is.
Seriously, okay.
I mean, you don't know?
Okay. No, I'm just sorry. Just not a big sports guy. I heard some stuff was happening in Atlanta.
Goes to the doors and walks away. That's it. I know. He's off to the hot tub tonight.
Actually, this weekend, my wife and son and I are joining the whole Cub Scout pack, and we're going to the Space Center in Huntsville, Alabama. So we're gonna spend an overnight there, and then get a special tour of the museum. And fly a space shuttle or something like that. What do they let the kids do?
Vomit coming.
Yeah, maybe there is one of those. Tom Hartnett, thank you so much for spending an hour with us. It's been a delight, and it's been too long since we've had you on. Thank you.
My pleasure. Some of these topics we could have spent an hour on completely. For example, how to groom your network and the diagnostics, and there's just so much to talk about. So I hope we got a lot. I think we got a lot in, and there's always more.
Well, we'll have your colleague, Chris Crump. He's been on the show a couple times. I'm sure we'll have him on again. And I know that Chris is going to be speaking to our Nashville SBE chapter sometime later this year. I'm not sure which month it is, but I've got him scheduled in sometime. So
good. Well, come out to NAB and see us if you get a chance.
Good idea. Yep. All right. See Tom and Comrex at NAB. And Chris, I suppose you'll be at NAB, won't you?
Yeah, I'm planning on it.
Okay.
TWiRT,
okay.
NAB. I'll be swinging by all the booths. Have some fun.
I'll be there for a whole week before it starts. That somehow Telos wrangled me to set up the booth. So yeah,
you're the guy that does the booth every year. That's a nice production.
I haven't done it in years, and they said, Kirk, we think we want your expertise setting up the booth. Okay, I just make all the lights flash and the stuff work. That's what I do. So. Oh well. Nice. Oh well. Hey, coming up next week, it's a War Stories episode, and Stephen Poole from Birmingham, Alabama, will be here, and he has got some war stories from us, including he's going to be talking about his world famous 3,000-year-old AC power generator. So that's what he called it anyway. That's coming up next week. Hey, I want to say thanks so much to all our sponsors. Be sure and patronize them. They're just terrific people. Thanks to Tom Hartnett and Comrex, and thanks to Chris Tobin, and a big thanks to Suncast, our producer, does a superb job. I really appreciate it. And we're going to go, and we'll see you next week on This Week in Radio Tech. Bye-bye.